Alright, in this video we're going to talk about igneous rocks. But before we can get into that, we have to step back a little bit. We're going to be using our flow chart from class, and we're going to be filling this out as we go. So let's get started. Now, we began this unit by studying minerals. And of course we know that minerals are the building blocks of rocks. They are what make up rocks. So we know all about minerals and their characteristics, and so we're going to look at what happens when minerals combine in nature to form rocks. But this brings up another question. There are so many kinds of rocks, like this sandstone and granite, this piece of gneiss, this piece of obsidian, and shale and pumice. All of these rocks exist in nature, of course, along with thousands of other varieties. And so the question arises, well, how do we classify them? Do we group them by their color, their texture, their density? What do we do? Well, it turns out that the best way to classify rocks is based on how they form, the way in which they come to be. So let's add that to our sheet here. This bubble under the word rocks, we're going to write that they're classified based on their method of formation, or simply how they form. And so if you do this classification, you will have three categories: igneous rocks, which we'll talk about today, sedimentary rocks, and metamorphic rocks. And so let's take a look at igneous rocks. So what exactly is an igneous rock? An igneous rock is a rock that formed from the cooling and solidification of magma or lava. Okay, let's add that. So they form from the cooling and solidification of lava or magma. Now what that means is that when molten rock cools down and essentially turns into a solid, that is what an igneous rock is formed from. When you think of lava and magma, you probably picture this molten material in the crater of a volcano, and that's exactly what we're talking about. But what I want you to keep in mind is that there is a difference between lava and magma. When it's deep inside the earth, under the surface, we call it magma. Once it erupts onto the surface, we call it lava. Now, this material, whether inside the earth or on the surface, can cool and solidify, and so that gives us two different types of igneous rocks. Igneous rocks are classified according to where exactly they did their cooling and solidifying. And so we have two types. And let's start with the first type. The first type of igneous rock is called an intrusive igneous rock. That means it formed inside the earth from magma. Now, as you can imagine, it's pretty hot inside the earth, and so that magma is going to cool very slowly. So magma cools slowly. And when it solidifies, it will allow minerals to form in crystals. But because it happens so slowly, those crystals are able to grow very large. And so intrusive rocks are always going to have very large crystals. Let's take a look. This is a piece of granite, and what you'll notice is that it's speckled. All of these speckles are different mineral crystals. The black is biotite mica, the pink is potassium feldspar, the white is quartz. But the fact that you can actually see them with the naked eye tells me that they're big enough to have cooled slowly inside the earth, and that this is an intrusive rock. If you want to know what I mean by big, any crystals larger than 1 millimeter signify that the rock is intrusive. But of course we can get really giant crystals like this pegmatite, where the crystals might actually be bigger than not a millimeter, but an actual centimeter. So we're talking about very large crystals here. So those are intrusive igneous rocks. But what about the second type? Well, as you might suspect, these are called extrusive igneous rocks. Instead of forming deep underground and cooling slowly from magma, these form on the surface. And because they cool really quickly from lava, you're going to get small or no crystals at all. And as a result, they may even have air bubbles trapped inside, which is something we call vesicular. So again, extrusive rocks form on the surface very quickly, and so you get very small or maybe even no crystals, and they may have air bubbles trapped inside. Let's take a look. This is a rock called basalt, and you'll notice that you can't really see any crystals at all. If you look with a magnifying glass, you would find really tiny ones that are smaller than a millimeter. That's a sign of an extrusive rock. What about this obsidian? Now this is interesting. It cooled so quickly in a matter of seconds that no crystals were able to form at all, and so you have this kind of glassy appearance. Finally, if it cools quickly enough, you might get air bubbles trapped in the lava and become part of the rock in the form of these vesicles or vesicular texture. You would look for air bubbles. So let's recap. A quick review. So igneous rocks form from cooled and solidified magma or lava. When it cools slowly inside the Earth, we get intrusive, sometimes called plutonic, igneous rocks, and they will have large crystals. When lava cools quickly at or near the surface, we'll get extrusive rocks, also called volcanic, that will have small or no crystals. They may be vesicular, meaning they have some trapped gas bubbles. Page 6 of the reference tables shows our common igneous rocks and their characteristics, and we'll be studying that chart in the coming days. Thanks.